Imagine standing in the middle of a flat, sun-blasted test range and watching the horizon begin to move. Not a convoy, not a tank, a single machine, so massive that your brain struggles to label it as a vehicle. It looks less like something built to drive and more like something built to intimidate physics itself. It rolls forward with a slow confidence, as if the ground was designed for it. This was the US military at peak Cold War ambition. When budgets were large, fears were larger, and engineers were asked to solve problems that sounded impossible on purpose. They built a vehicle so enormous it could carry a small house, cross broken terrain, and keep moving where roads didn't exist. It was meant to be a symbol of unstoppable logistics, a mobile base that could deliver power, supplies, and survival into places where normal machines would die. And then, after all that effort, all that money, and all that engineering, it was left behind. Not in a museum, not in a hangar, in the desert, abandoned like an idea the world decided it no longer needed. So what was this monster? Why was it built? And how does something that extreme go from strategic breakthrough to forgotten wreck in the sand? The strangest part is that this kind of story is not a one-off. The military has a long history of building almost impossible prototypes, because prototypes are a way to buy information. They reveal what works, what breaks, and what the next decade might demand. But when a prototype is enormous, the difference between experiment and obsession becomes thin, and the desert is often where that line finally shows up. Before starting this video, remember to subscribe and like it. To understand how the military ends up building a vehicle that feels too big to be real, you have to understand the Cold War mindset. The United States was planning for scenarios where traditional infrastructure could not be trusted. Bridges might be destroyed, ports might be bombed, roads might be cratered or contaminated. Supply lines, always the fragile heart of any war, could snap overnight. So planners started asking a terrifying question. What if we had to move huge amounts of material across hostile terrain without relying on roads, bridges, or rail? What if we needed a machine that could carry heavy loads, survive harsh environments, and keep functioning even when the world around it was broken? That question leads to one word: logistics. Not the glamorous part of war, but the part that decides outcomes. If you can move fuel, equipment, shelters, and personnel reliably, you can operate where your enemy can't. And if you can do it with one massive platform instead of many vulnerable trucks, you reduce complexity and increase control. Engineers responded in the most American way possible, by scaling up. The concept was to build an ultra-heavy, ultra-wide, multi-wheel vehicle capable of traveling over soft ground, sand, and uneven terrain without sinking. Instead of concentrating weight on a few axles, it would spread that weight across many wheels, lowering ground pressure and increasing stability. The design would carry enormous payloads, either as a single platform or as a modular system that could haul different mission packages. But as the concept grew, it stopped being a truck and started becoming a rolling experiment in physics. Steering became a problem. Power delivery became a problem. Even maintenance became a problem. How do you service a machine that large in the field? Still, the logic was seductive. If it worked, it could redefine mobility. It could deliver heavy equipment to places where helicopters couldn't lift and where conventional vehicles would bog down. It could move supplies with fewer trips, fewer drivers, and fewer vulnerable points. And in that era, seductive logic plus national fear was enough to build almost anything. In the background, there was also a psychological race. The Cold War wasn't only fought with missiles and speeches, it was fought with demonstrations of capability. A machine that could traverse terrain no road vehicle could handle wasn't just useful. It was a signal to allies and enemies alike that the US could operate anywhere, even in the worst conditions. That kind of signaling can justify experiments that would look irrational in peacetime accounting. When the project moved from concept to metal, the engineering challenges multiplied fast. Building something huge is easy on paper. Building something huge that can actually move, reliably, controllably, and safely is a different universe. The first challenge was weight distribution. A vehicle of this scale needed dozens of wheels or tracks to avoid sinking. That meant complex suspension systems, multiple drive units, and a structure strong enough to hold everything together without flexing itself apart. Every bump became a structural event. Every turn became a stress test. Then came propulsion. You can't simply put a normal engine in a machine like this. The vehicle required immense torque at low speeds, the ability to crawl over obstacles, and enough power to keep the system moving under load. Designers often explored multiple engines, generator motor arrangements, or other hybrid approaches that could route power where it was needed. Reliability mattered more than speed. The vehicle wasn't meant to race, it was meant to be unstoppable. Steering was another nightmare. The longer and wider a vehicle gets, the harder it is to turn. Traditional steering geometries break down, so engineers experimented with multi-axle steering, differential drive, or articulated sections, approaches more common in heavy mining equipment than in military vehicles. The vehicle needed to maneuver without tearing up its own tires or locking itself into wide, useless arcs. And then there was the human factor. A vehicle this large can't be driven like a normal truck. It needs systems, controls, feedback, instrumentation to keep it stable. It needs a crew that understands what the machine is doing, because if something goes wrong at this scale, the consequences are huge. A small failure can become a catastrophic one. As testing began, the machine did what prototypes often do. It proved the concept and exposed the pain. It could move, it could carry, it could roll over terrain that would defeat smaller vehicles. But it was expensive, complicated, and specialized. Every hour of operation revealed a new component that needed reinforcement, redesign, or constant attention. Still, in the Cold War, prototypes didn't have to be perfect to be valuable. Sometimes, they were built to explore the edge of what was possible and to show competitors what might be coming. Another challenge was logistics of the prototype itself. The test crews needed spare parts, specialized tools, and sometimes custom lifting equipment just to service it. Every maintenance cycle became an operation. That reality matters because a system that requires a small army to keep it alive can accidentally create the very vulnerability it was designed to solve. Testing also revealed trade-offs. Spreading weight across many wheels improves flotation on soft ground, but it increases the number of components that can fail. Steering systems become more complex. Tire wear becomes a budget item. And because the machine is unique, off-the-shelf fixes don't exist. The prototype teaches engineers, but it also teaches accountants. For a brief window, the giant vehicle represented a real strategic fantasy, a world where the US could deploy massive capability across broken landscapes, bypassing destroyed infrastructure and operating in places that looked impossible on a conventional map. But strategy is not only about what you can build, it's about what you can justify, financially, operationally, and politically. As the years moved on, the battlefield assumptions changed. Airlift improved, helicopters got stronger, cargo aircraft became more capable, containerization and improved logistics planning reduced the need for a single rolling behemoth. Instead of betting on one giant machine, planners could spread risk across many smaller systems. And the giant vehicle had a vulnerability that no amount of engineering could fix. It was too singular. If it broke, an entire capability disappeared. If it was targeted, it became a massive, obvious prize. If it got stuck, it wasn't a quick tow job, it was a crisis. There was also the issue of infrastructure in reverse. A vehicle built to ignore roads still has to interact with the world. It has to be transported to the theater. It has to be stored. It has to be fueled. It has to be maintained. The bigger it is, the more it creates its own logistical tail, exactly the thing it was supposed to reduce. Meanwhile, budgets tightened and priorities shifted. Projects that felt like science fiction became harder to defend. Commanders wanted systems that could be produced in quantity, deployed quickly, and integrated into existing doctrine. The behemoth was impressive, but it didn't fit neatly into the evolving military machine. So the project moved from future cornerstone to interesting experiment. The testing continued, but the momentum faded. And once momentum fades in defense procurement, the end is usually quiet. Fewer updates, fewer funds, fewer champions. Eventually, the decision was made, officially or effectively, to stop. And what happens to a prototype that is too big, too specialized, and too expensive to keep? There's a moment in every large defense program when decision-makers stop asking, "Can it be built?" and start asking, "Can it be fielded?" Fielding means training, manuals, supply chains, deployment plans, and integration with other units. It means writing doctrine around the machine. The behemoth struggled at that step, not because it was useless, but because it was too different. As alternatives improved, the behemoth's advantage narrowed. Smaller vehicles became more capable with better tires, better suspensions, and better route planning. Airlift and sea lift improved. In many scenarios, flexibility beat raw scale. And when flexibility wins, giant single-purpose machines start to look like liabilities. This is where the story turns from engineering to fate. A vehicle of this size doesn't have an easy afterlife. You can't just park it behind a warehouse and forget it. You can't easily ship it to a museum. You can't auction it off to a civilian buyer. It's not a collector's item. It's an industrial-scale object built for a specific strategic dream. So it ends up in the place where many military dreams go to die. The desert. Deserts are where the military tests, stores, and retires. Wide open spaces, dry air, isolation. It's where equipment can sit for years without rusting as fast as it would elsewhere. It's also where things can vanish from public memory. The desert doesn't just preserve metal, it preserves secrecy and neglect. Once abandoned, the behemoth becomes something eerie. It looks like a relic from a parallel timeline, a future that was imagined and then cancelled. Sun bleaches its surfaces, sand drifts into its cavities, tires crack, wiring degrades. The machine that was built to be unstoppable becomes a still life. And then the myth begins. People hear rumors, they see photographs, they argue about what it was for. Some assume it was a weapon, others assume it was a hoax. But the truth is more human. It was a sincere attempt to solve a problem that stopped being urgent. In a way, abandonment is the final test, not of strength, but of relevance. The desert becomes a museum without labels, where the only question is, did this machine matter enough to be remembered? For the people who worked on it, the abandonment can feel like betrayal. Years of labor reduced to silence. But for the military, it's a pragmatic decision. Technology moves, threats move, and what doesn't fit the new map gets left behind. The desert doesn't judge, it just waits. Abandonment also creates a unique kind of legend, because it feels wrong on an emotional level. People expect powerful nations to preserve their achievements. But bureaucracies don't preserve. They allocate. When a project is cancelled, its assets are evaluated. Reuse, storage, disposal. The bigger and stranger the asset, the less likely it is to find a new home. Sometimes the desert becomes the only realistic option. It's cheaper to park the machine and strip what can be reused than to spend enormous sums moving it. Over time, stripped parts and missing panels can make the vehicle look mysteriously destroyed, when the truth is simply practicality. The military salvages what has value and leaves what doesn't. So why does this story still fascinate people? Because the biggest vehicle in history, built with serious intent, exposes something fundamental about how power thinks. When a nation is afraid enough, it will build on a scale that borders on absurd. It will fund prototypes that exist not because they are efficient, but because they make a statement. We can do this, therefore we might do this. But scale has a cost. A giant vehicle is not just a machine, it's a philosophy. It assumes that one massive solution can replace many smaller ones. It assumes that technological dominance can be consolidated into a single platform. And history rarely rewards that assumption for long. What the abandoned behemoth really represents is the tension between imagination and implementation. Engineers can build extraordinary things, but strategy changes faster than steel. By the time the machine is ready, the world may have shifted. New technologies may have made the original problem irrelevant. New doctrines may have redefined what winning looks like. And that's why the desert is full of ghosts. Not supernatural ones, engineering ghosts. Machines that were built for a future that never arrived. The biggest vehicle in history isn't just a curiosity, it's a warning. The line between visionary and obsolete can be crossed in a few years, and the more extreme the project, the harder it is to adapt. In the end, the behemoth didn't fail because it couldn't move. It failed because the world moved without it. And that's why viewers love this kind of story. It's a collision of two things we rarely see together: extreme imagination and extreme consequence. The behemoth represents the dream of brute force solutions. Build it bigger, spread the weight, overpower the terrain. The desert represents the counter-truth. Relevance is the only fuel that matters in the long run. The machine becomes a monument to how quickly a strategic environment can change. A weapon system might become obsolete because a new sensor appears. A vehicle might become obsolete because doctrine changes. Even a brilliant prototype can be left behind if it no longer answers the most urgent question. The US military built a vehicle so massive it felt like an argument against limits. And for a moment, it won that argument. It rolled, it carried, it proved that scale could be engineered. But history doesn't preserve machines. It preserves needs. When the need disappeared, the biggest vehicle in history became just another artifact, left under the desert sun like a sentence unfinished. And that's the haunting part. Not that it was abandoned, but that it was built at all. Proof that somewhere in the Cold War, the future was so uncertain that bigger than anything felt like a reasonable plan. So if you ever see an image of a colossal military machine half buried in sand, remember what it really is. A snapshot of a moment when fear, money, and engineering pointed in the same direction. The desert didn't defeat it. Time did. As always, if you like this video, don't forget to subscribe and leave your like. See you in the next video.